So this is me. I work at NASA and I'm an astroparticle physicist. I also really love to talk about my job because I'm kind of a geek. And these are my parents. They like to call me every once in a while. See, that's my mom, that's my dad. And they'll call me up and they'll ask on the phone, "So honey, what's going on at work?" And like I said, I love to talk, so I'll tell them. I'll be like, blah blah blah, gamma particle decay, blah blah blah, pions, blah blah blah, gamma rays. Basically, I'll talk about exactly what I love to talk about, confuse everything a lot. My father will just go dot to dot. "That's nice, honey." And I realized this is kind of a huge problem. You see, the thing is, I just want everyone to love astroparticle physics as much as I do. I love astrophysics almost as much as I love cats. Meow. So then I had this great idea. What if I just made astrophysics as explained by kittens? Everyone loves kittens, and then they could love astrophysics too. So here's the thing. Basically, you think of astrophysics, well, you think of observing anything, as just some bro on the ground with a telescope looking up at the stars. But once I got to my job, I realized, there's a lot more to it than just that. If you just think of it that way, you're really missing a lot. So, because the thing is if you're just looking up, all you're looking up is with your eye, and your eye misses a lot. There's a whole lot of other ways, and you can use really fancy scientific instruments to see a lot of things that you'd miss if you were just using the human eye, because it's kind of limited. So you have satellites, and you have stuff like big radio telescopes, and all of these I think are, quite neat. So now, consider a room of cats. You have a cat in the middle, and he just sort of listens to his favorite tunes. He's swaying along to the melody, sort of enjoying himself, slightly rocking back and forth. And then a cat over here is a very grumpy cat, and he's basically sitting still as he can. He's slightly moving, but you can't see him. He just looks like a rock to you. And there's a cat over here. Now someone's been stupid and given this cat Red Bull, so he's moving really fast back and forth. Now imagine you had a cat that was moving so fast that you couldn't even see him. It was like poof, he disappeared. So now, if someone asked you which cat looks like it's moving, you'd really only be able to say that the middle one looks like it's moving. The one on the left is moving, but it's moving too slow, and the one on the right is moving, but, it looks like it's moving too fast. Well, now you see what I did here, is I've just tricked you. I've just made a clever metaphor for particles. And these particles we're talking about are photons, and all you really need to know about them is that they're little bits of light. And I'll explain more about that later, so don't worry. But these little bits of light come in different degrees of fast movingness. And you have the slowest ones, which are called like radio waves, microwaves, infrared waves. Then you have ultraviolet rays, X-rays, and gamma rays, which is the one that I deal with. Now, like I said, remember, these gamma rays move too fast for you to be able to see. So you need to use some kind of clever way of looking at them in a different way. And that's where you use my scientific instrument that I use. It's a big satellite, and its name is Fermi. It collects this gamma ray data from the highest energy, fastest moving particles in the universe. This satellite collects that data and then sends it back down to Earth to my computer where I analyze it and finds out about all sorts of really cool space things. And from that you can learn about stars that go boom, which are called supernova remnants, exploded stars. You can also learn about black holes, which, who isn't interested in black holes, and pulsars. But, I'll go into more detail about all of those cool things in a later video. Thanks for tuning in.